To build a time machine with your eyes, all you have to do is open them and look at the sky. In the previous episodes, we saw many stars die, but before a star ends its life, a sun first has to begin its life. So today, let's go discover their birthplace. Let's start by looking at the gigantic cradles known as the pillars of creation. Here, nature has built what we call a stellar nursery. This temple, which isn't solid at all, is made of clouds whose dimensions are extraordinary, enormous. A single pixel on an image like this equals the distance from the Sun to Neptune. This tiny spot here is 170 billion kilometers long, and each of these columns is heavier than 1,000 suns combined. At the top of the left pillar, which is 4 light years tall, there are tiny droplets of gas and dust hanging in suspension, each of which is actually larger than our entire solar system. Hidden, surely buried inside these veils, are dozens of new stars being formed and others perhaps soon about to die. Because the pillars of creation are also a place of destruction. They form a monumental temple, without a roof, without protection. As evidenced by these long filaments of hydrogen being torn away from them by powerful stellar winds and the ultraviolet radiation emitted by young massive stars located out of frame, and which, although they are light years away, are powerful enough to slowly erode and sculpt their peaks. As immense as they are, these 3 pillars are just a tiny part of an even larger structure, the Eagle Nebula, where there is another column, this time 10 light years long. For a probe like Voyager 1, which is currently speeding through space at over 60,000 kilometers per hour, it would take nearly 48,000 years to travel from its base to its summit. And the Eagle Nebula itself is just one among thousands of other clouds, of various shapes and sizes, drifting in our galaxy. Like this one, at the center of which is a giant star, illuminating its birthplace from within, like a fire's flame lighting up its own smoke. And despite its diameter of about 20 light years, the Trifid Nebula is a dwarf compared to the Tarantula Nebula, which stretches and spreads its reach over a region 75 times larger. To travel from one end of this web of gas and filaments to the other, light takes 1,500 years, and the Voyager 1 probe would take about 7 million years. All the layers of dust and gas found here contain more than 500,000 times the mass of our Sun. An impressive figure which might lead you to think that these formations are extremely dense. But the eye can be deceiving because, as opaque as it may be, a vast cloud of interstellar gas and dust like this one contains on average only a few thousand molecules per cubic centimeter. A ridiculous number compared to the 20 billion found in a single cubic centimeter on Earth at sea level. To try to visualize this difference in density, imagine the volume of an Olympic swimming pool filled with air. Contains, roughly speaking, the same number of molecules as 3 times the volume of our planet in one of these nebulae, whose density still remains gigantic if you compare it to that of the surrounding space. Because in the interstellar medium, between the stars and the nurseries, there is on average only 1 particle per cubic centimeter. Such a tiny amount that there are more molecules on Earth. In a cylinder 1 meter long and the diameter of your eye, there are more molecules on Earth than if you held the same cylinder out into space, starting from your eye, to reach the center of our galaxy, which is about 50,000 light years away from here. A few thousand molecules per cubic centimeter becomes a number full of promise on the scale of a nebula 200 light years in diameter, like the Carina Nebula, where, in cold and dense regions, this number can rise to several million particles per cubic centimeter. Enough to give birth to about 14,000 stars. And in these gas envelopes, there are still enough reserves to ignite tens of thousands more. Some will have relatively calm lives like our Sun, and others, supermassive and unreasonably large, will end their lives in cataclysmic explosions. Such is the fate that inevitably awaits Eta Carinae A, In the mid-1800s, Eta Carinae was shaken by violent outbursts that released the equivalent of about 10 solar masses into space and made it the second brightest star in the sky for 20 years. The traces of this spectacular activity are still visible in the form of two gigantic lobes extending from the system. Hidden behind the veils formed by these explosions, the star itself is no longer even visible. This giant star is also there to remind us that the stars forming in these immense structures do not always leave their cradle. Some will even die there, like Eta Carinae A, because more massive than 100 suns, this star will soon turn into a hypernova. And when it explodes, even though it is located 7,500 light-years away from us, it will light up the night in the southern hemisphere as much as a full moon. And its explosion will release more energy than all the stars in the nebula combined over the course of their lifetimes. And it will also wipe out part of the nursery. This cloud that the star is making glow red is also on borrowed time, because even though it's located several light years away from the hypernova in the making, the blast from the explosion will inevitably disturb it. About 20 light years away from there, other stars are gradually sculpting and unraveling the Carina Nebula from the inside. This entire region has been almost cleared of most of its gas, now pushed to the outskirts by the activity of previous generations of stars, whose violent outbursts have carved out and disturbed the surrounding space. As for these two giant stars, through their intense activity, they have managed to shape and break up clouds that are nevertheless 10 light-years away. The ultraviolet rays they emit are capable of exerting enough pressure to compress the hydrogen walls in other parts of the nebula, thus initiating their contraction and then their collapse. The stars that are probably being born here are still hidden under mantles of dust, but they reveal their presence by forming jets of matter that they propel into space. The Carina Nebula, the Eagle Nebula, or the Tarantula Nebula, all these structures are dotted with dozens of such islands of matter, isolated or in groups, wispy or clustered, of all shapes and sizes. It's me, where the universe points a finger at us. A gigantic finger, like everything here. The scale of these nebulae is hard to grasp, since even the smallest detail can take on insane proportions. In this image, every bubble of gas shaped by the power of radiation from nearby giant stars is larger than our solar system. As for this bubble, it surely hides a forming star, but for now, the star inside is still veiled by dense gas rich in particles about a micron in size. A size comparable to that of the particles in our fireplace smoke. Soon, almost all of these grains of matter will contribute their accumulated mass to trigger the birth of a star at the center of a contracting cloud. Like here, where the gas bubble glows under the action of a newly formed sun. All the nebulae present in the sky are thus tapestries of births and deaths, which follow and influence each other in a continuous cycle, from collapsing clouds igniting suns that in turn sculpt the surrounding gases. The most massive stars born here, through their outbursts and explosions, will help enrich other clouds with heavy elements forged in their cores, and maybe even go so far as to trigger the birth of a second generation of stars at the other end of the nebula. Broken down, sculpted, or slowly devoured from within by successive generations of suns that live and die there, all these nebulae are ultimately doomed. Their typical lifespan is estimated to be a few tens or even hundreds of millions of years. That's the time it takes for all the matter that makes them up to be expelled and diluted into space by giant star explosions and high-energy radiation. Or they end up in smaller stars, which will live long enough to see the nebula that gave birth to them fade away. These stars will then be the last remnants of those immense cradles that have disappeared. Our Sun, which was born, along with its group of planets, in such a cosmic crucible 4.6 billion years ago, still retains the memory of it today in the form of certain atoms it contains and is not able to produce itself. Atoms that only giant stars could forge, and in this sense, our Sun also has parents. It is a star of a more recent generation that formed from a cloud enriched with the remnants of dead stars brought by generations of massive stars that enriched the now vanished nebula with heavy elements. And that's also the case for all the stars that can be seen with the naked eye from Earth. On a beautiful moonless night with the naked eye, there are about 2,000 of them. With binoculars, this number rises to about 50,000. With a small telescope, around 300,000. An enormous number and also in itself ridiculously small. Because if you have the high-precision Gaia satellite, you can then create the largest star catalog ever made, in which the positions of 1.7 billion stars in our galaxy are precisely detailed. This striking map of our Milky Way, which is also the most detailed one we've ever made, only puts a tiny fraction of the 200 billion stars it contains in this spotlight. And our galaxy itself is just one of the 2 trillion galaxies in our observable universe, which is surely only a tiny part of our universe. What are we celebrating? Our birthday. I wasn't born on the same day as you, but one of them was. Which one? Well, I don't really know. But since, on average, every year in our galaxy, 1 star is born, if we look at the observable universe, I did the math, that's 380,000 births per minute. There are 6,300 stars up there born in the same second as us. I hope you didn't invite them all. To stay switched on, remember to hit the bell so you can follow the whole series. And if you like useful or trivial content, you can also follow us on Instagram, Twitter, or Facebook.